One of the questions that many instrumentation and control engineers ask is, when should we force a signal? And when should we apply MOS, maintenance override switch? The definition of forcing is straightforward. It means fixing a signal at a constant value so that the control system always sees that predefined value, regardless of the actual process condition. MOS, maintenance override switch, on the other hand, is different. Applying MOS means temporarily bypassing the safety action associated with a particular signal during maintenance activities. For example, imagine that a compressor is configured to trip whenever the suction temperature reaches a high limit. If you apply MOS to that safety input, the compressor will no longer trip even if the high condition actually occurs. Now let me explain the difference through a real industrial experience. A preventive maintenance PM job was scheduled on the compressor suction flow meter. Before starting the work, the operator checked the list of available MOS points. Since the suction flow meter was not included in the MOS list, he assumed that performing maintenance on this instrument could not trip the compressor. The maintenance team started working on the flow meter. A few seconds later, the anti-surge valve suddenly opened fully. As hot recycle gas flowed from the discharge side back to the suction side, the suction temperature increased rapidly and eventually reached the high limit. As a result, the compressor did not trip because of the flow meter itself. Instead, it tripped because of the high suction temperature. This is exactly where the importance of forcing becomes clear. The flow meter itself is not a trip initiator, but losing its signal creates a secondary effect that ultimately causes a trip. So what should we do in this situation? One option is to force the flow meter signal during the PM activity. By doing so, the temporary signal disturbances caused by maintenance are prevented from affecting the control system. Another option is to switch the anti-surge control valve to manual mode before starting the maintenance. In that case, even if the flow meter signal is lost, it will no longer influence the valve position. As you can see, applying MOS to the flow meter does not make sense in this scenario because the flow meter itself is not a safety trip input. Forcing the signal is the appropriate solution. Likewise, applying MOS to the suction temperature signal would be a poor engineering decision because doing so could disable an important protection function and expose the compressor to serious damage.